Hi everyone. Today we're going to just kind of take care of some basics having to do with polynomials to get us ready for this new unit that we're starting today. So a lot of the stuff I'm going to be going over should be review for you, but I kind of want to make sure everybody's on the same page. I want to dust off the cobwebs a little bit. So it's going to be pretty straightforward. After you watch the video, you can go ahead and do the assignment. It's short. It's only 1 page long. You'll see it on the class page, and I'm going to just kind of do some example problems that follow along with the worksheet. Okay, so the first thing we're going to do is talk about evaluating expressions. And a lot of times people they think they understand all of this stuff, but I do want to just go through it briefly because there are a few minor nuances with it. When you're talking about evaluating expressions, we're talking about something very basic when you're dealing with a number raised to a power. This is something that we're all familiar with, right? 3 squared is just 9, and you could have any power you want. You could have 3 to the 4th. That would be 81. And these you can certainly figure out in your calculator as well. You can use your calculator to solve those higher powers. But a couple of things that I want to make sure that we're clear on. There is a very big difference between negative 3 squared and negative 3 squared. These two are very, very different. Visually, they're different because one has parentheses and one doesn't. But mathematically, they're different as well because they do produce different answers. When you have a negative in front of a number and there's no parentheses, here's the one thing you want to remember. This exponent only applies to what it's directly next to. That 2 is directly next to the 3, so it actually only applies to the 3. It doesn't also apply to the negative in front of the 3. I can actually rewrite this as negative 1 times 3 squared. Okay, order of operation says you have to do the exponent first, so that's the same as negative 1 times 9, which gives you negative 9. That's very different than this. In this one, your 2 is next to the parentheses, so it applies to everything that's in the parentheses. So this is the same as negative 3 times negative 3. A negative times a negative is a positive, so that would give you positive 9. So you see the difference in those two answers there. It's really important that you understand there's a difference when you have parentheses versus not having parentheses. That's also why I tell you when you're entering stuff in the calculator, always put it in parentheses because then the calculator will always produce the answer that you want. Okay, unless something isn't written with parentheses, then you wouldn't put it in. So this first example, I wouldn't use parentheses, but the second one, I would. I'll show you some examples when you'll always use parentheses as well. One other quick thing is when you're dealing with a fraction raised to a power, we talked about this when we were completing the square. Remember, if you have a fraction raised to a power, you raise both the numerator and the denominator to that power. Okay, so 4 squared would be 16, and 5 squared would be 25. Okay, very straightforward stuff there, but just a quick review. So when you are given a polynomial, which we'll talk about polynomials a little bit more in a second. When you're given a polynomial and you're asked to evaluate it for a specific x value, so x equals negative 3, for example. When you are substituting a number into an expression, make sure you put that number in parentheses. Always, 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 because then you'll always get the right answer. If I don't put this in parentheses, then this is going to give me the wrong answer. Remember that this this exponent applies to what it's directly next to. It's directly next to x, so it's going to apply to all of x, which means I want to make sure that I put all of x in parentheses. That way that power applies to the whole thing. always put it in parentheses, and then you'll always make sure that you get the right answer. Okay, so here you would have 9 minus 6 minus 8, which would give you negative 5 as your answer. Okay, you can put this in your calculator, just make sure that you use parentheses when you're doing that. Okay, let's talk about multiplying and dividing with monomials. When you multiply things with the same base, make sure that you add your exponents. So for example, if I have 3x to the 5th times 15x to the 8th. Okay, I'm multiplying my coefficients together, so 3 times 15 would give me 45. And then because I'm multiplying two things with the same base, I'm going to add their exponents. That would give me x to the 13th. Okay, with exponents, you add them with coefficients, or those numbers, you multiply them. So if I had negative 4x to the 5th, y to the 3rd, times 7x y to the 4th. Okay, multiply my coefficients together. I get negative 28, and then I'm going to go ahead and add my exponents. So x to the 5th times x to the 1st, because there's no number written there, so that's just 1. If I add 5 and 1, that gives me 6. Then look at your y's. Y to the 3rd times y to the 4th. You're adding your exponents, and that gives you y to the 7th. So multiplying is very, very straightforward. Just make sure that you add those exponents. When you are talking about dividing, 8x to the 9th over 2x to the 3rd. Okay, just like up here you multiplied your coefficients, here you're going to divide your coefficients. So 8 divided by 2 would be 4. Okay. Now, some people want to divide their exponents here, and you're not going to do that. Do not divide your exponents. You are going to subtract your exponents. When you were multiplying, you added your exponents. Now that you're dividing, you subtract your exponents. So here I would have x to the 6th. 9 minus 3 gives me 6. Okay? When you are doing division, this is where people tend to make careless mistakes. That's where they make their mistakes most often. You've got 20 x to the 3rd y squared over 5 x to the 4th y to the 5th. Okay, remember you are subtracting your exponents. So first we're going to divide these numbers. So 20 divided by 5 would give me 4. Okay, x to the 3rd minus x to the 4th would give me x to the negative 1. 3 minus 4 is negative 1. 2 minus 5 is negative 3. When you have a negative exponent that does not make the number negative, all it does is move that term to the denominator. If it's negative in the numerator, it moves it to the denominator and makes it positive. So my 4 is going to stay in the numerator because that doesn't have any exponent to it. I have 4. This x to the negative 1 is going to go to the denominator, and now it's going to be positive. This y to the negative 3rd is going to move to the denominator, and now that exponent is also going to be positive. So this expression and this expression mean the same thing. It's just different ways of writing it. One other thing that will help you out when you're looking at this, look at where the larger exponent is. That is where that variable is going to end up. So for example, x to the 4th is bigger than x to the 3rd. Since x to the 4th is in the denominator, that variable is going to be in the denominator. Same with your y's here. The larger one is in the denominator, So your answer is going to end up in the denominator. With my coefficients, 20 was bigger than 5. So when I simplify that, the number stayed in the numerator because that's where the larger number was to begin with. So for example, if I have 3x to the 8th y squared over 9x to the 5th y to the 5th. Okay? My larger number here is in the denominator. So 3 divided by 9 would be 1 divided by 3, or 1 over 3. Okay, I'm just reducing the 3 and the 9. X to the 8th over x to the 5th. If I subtract my exponents, I have 3, so I would have x to the 3rd. Because my larger one was in the numerator, it stays in the numerator. Y squared over y to the 5th, that's the same one we just did over here. That would give me y to the 3rd if I subtract my exponents, right? I end up with 2 minus 5, which is negative 3. But my larger one is in the denominator, so I'm going to move that to the denominator and make it positive in the denominator. So you could just write that as x to the 3rd over 3y cubed. So very important that you make sure you understand where those terms go. Okay, let's talk about identifying the degree of a polynomial, or a monomial for that matter. A monomial, remember, is one term. A binomial would be 2. Trinomial would be 3. Polynomial would be just anything, any type of, any number of terms you can refer to as a polynomial. When we talk about the degree, we're talking about the exponent. So let's say, for example, I have 5x to the 3rd. That would be a 3rd degree polynomial. Okay, 3rd degree. However, sometimes you don't just have one variable. Sometimes you have multiple variables. Let's say I have 6x squared y to the 5th. In that case, you're going to add those exponents together. So if I add 2 and 5, that gives me 7. So that would be a 7th degree polynomial. Okay? So when you have multiple ones, make sure you add them together. When you are writing a polynomial in standard form, so I have x squared minus 8x to the 5th plus 7x cubed minus 12. Writing it in standard form means you start with the largest exponent and then you work your way down as you write them. So my first term here is going to be negative 8x to the 5th, and then my next largest exponent is the x third, or x to the 3rd. So I have plus 7x to the 3rd. My next largest exponent would be the 2, so I have plus x squared, and then I have negative 12. This is in standard form because I'm starting with the largest exponent and then I'm writing the exponents in decreasing order. When you see the term leading coefficient, that's talking about the number that's in front of the largest exponent, the variable with the largest exponent. So in this case, my leading coefficient is negative 8. Okay, each of these are considered terms. So negative 8 to the 5th is a term. 7x to the 3rd is a term. All of these are terms that make up this 5th degree polynomial with a leading coefficient of negative 8. So that's all the terminology that you're going to be seeing as we go throughout the unit. Okay, one other thing is just about adding and subtracting polynomials. Make sure you combine like terms, so x squared plus 7x plus 3x squared plus 8. Combine your like terms, so I have x squared plus 3x squared gives me 4x squared plus 7x plus 8, and that is in standard form. Combine your like terms when you're adding or subtracting. That's about it. You should be all set. I'll see you guys in class tomorrow. Take care. Bye.